Picking up where we left off, with the sample project opened and simulations completed, move your mouse to the main menu, click on the Retrieval command, and look at the drop-down list. You have options to retrieve time series results and water surface profiles, export time series data, and print run summary reports. In this tutorial, we are going to take a bite-sized look at the Retrieval system, focusing on time series retrieval. When you select the time series menu item, Chan lists the parameters available for retrieval, including basin runoff, source flow and runoff to nodes, stage, flow, and velocity. Our sample problem is a pre-post analysis, so let's start by retrieving runoff from basins. The time series retrieval form opens with an empty grid. Click on the plus button to add a series to the grid, and then select a scenario from the drop-down list. Let's look at results from the 25-year scenario. Chan displays a list of basins. Select a basin and click on the Select button, or double-click on a basin in the list. The time series grid is populated with basin hydrograph data for the selected feature. Now select the post-development basin. There are no more basins to add to the grid, so close the element selection dialog. With the grid populated, you can scroll and view the hydrograph data values. Click on the Graph button to display individual runoff hydrographs as line graphs. The scenario and feature IDs associated with the graphed series are displayed in the subtitle. Click on the directional arrow buttons to scroll and view graphs for all features contained in the grid. Click on the Overlay button to compare hydrographs. The base feature of an overlay graph is drawn with a thick black line style. You can again use the arrow buttons to scroll to the item that you want to display as your base feature. The graph is scaled to fit to your base series selection. Now select a feature from the drop-down list to overlay model results. A legend is built, listing the scenario and ID of each overlay. The legend can be relocated to any of the four corners of the plot area by double-clicking on a legend symbol. Overlay features can be removed from the graph by double-clicking on their label. Let's make a few other quick changes to the graph display. First, if you double-click anywhere within the graph area, you will be able to cycle through the display of horizontal and vertical grid lines. Grid line intervals are automatically computed based on the axis ranges to provide a clean look to your graph. Axis ranges are initially set to fit the base series. Move the mouse to any axis label and double-click to manually reset the scale. Let's change the runoff axis to 60. The grid interval has increased to maintain focus on the time series data, and not on the grid itself. The result is a nice, uncluttered graph, but most of the action in a runoff hydrograph occurs in a short time window. You can effectively zoom in to view your results in greater detail by changing the minimum and maximum axis values. Here, let's change the minimum time to 10. Let's also change the maximum time to 20. Now we can clearly see the effect of post-development imperviousness, with our peak discharge increasing from 30 to almost 55 cubic feet per second. Let's roll up this time series dialog and see if we are meeting discharge criteria at our pond outfall. We can open another time series dialog to retrieve a discharge hydrograph for that feature. Select Flow and Reach and click OK. Now click the plus button to add data to our grid. Let's retrieve results for all three storm event scenarios, starting with the mean annual event. Each time we will just select one reach, the culvert riser that controls flow from the wet detention pond. Now, let's get the 25-year simulation results. And, finally, the 100-year results. Once the grid is populated, we can close the dialog and click on the Graph button to view the selected post-development discharge hydrographs as line graphs. Use the arrow buttons to display the 25-year discharge hydrograph. Let's toggle the grid lines on so we can estimate our values. The peak rate of discharge for the 25-year storm looks to be about 15 cubic feet per second. Let's switch back to the basin hydrograph plot. The change in impervious area from 0 to 35% increases the volume and the rate of runoff. The wet detention pond and outfall structure are designed to make up for the difference in peak runoff rate. In other words, the 55 cubic feet per second post-development runoff rate must be attenuated in the pond so that discharge from the site is less than the 40 cubic feet per second pre-development runoff rate. This pond is shown to attenuate the 25-year post-development discharge more than adequately. This initial look at time series provides a glimpse of the Chan retrieval system. There is much more to cover, so check back frequently as we expand the tutorial selection.